All right, so for the graph of y squared equals to x, this is, if you think it looks familiar, this is actually just the reflection of the graph y equals to x squared. And note that y equals to x squared is this shape here. Okay, this is a parabola. And so y squared equals to x is just the same parabola, but horizontally. All right, so it's a horizontal parabola here. Right. Okay. Now, there's a special version, because remember how when this form here, in order to sketch it, the easiest form is y is equals to a x minus h everything squared and then plus k, right? In order to get the same version, and note that h and k in this form, the the turning point would be just h and k. So what is the similar turning point form for the graph of y squared equals to x? Well, let's rearrange this equation a little bit. So you would get y is y minus, so I'll move the k over to the left hand side. Y minus k equals to a times x minus h everything squared. Okay, and note that at this point, the y minus k looks very similar to this formula here, right? It's just that instead of y, you're getting y minus k. And then instead of x squared, you just get the single x here. So actually this one will help you remember how to get the other version. Because remember, this y squared equals to x, the y becomes y squared, and then the x squared becomes just a normal x. So you see, if the right hand side, right, becomes y squared, so you technically make everything y related. So actually you should divide by a here. You make everything y related, square that. So the turning point form will be y minus k everything squared over a squared. And then the x, instead of squaring the x, you just leave the x by itself, x minus h. Okay, and then we'll do one more step. We'll times the a squared back in there. So y minus k everything squared equals to times the a squared back into the right hand side, a squared x minus h. Now this one will also give you the turning point is equals to hk. Okay, so that will be the easiest. So turning point is still h and k, and if x is positive, aka if the a squared value is positive, then it will well, if x here is positive, then it will go in a positive direction of the x-axis. Okay, if you have something like y squared is equals to negative x, then this graph will just be reflected, right? Instead of positive x, you get negative x. It will just be the hyperbola in this direction here, in the negative direction of the x-axis. All right, let's try out these examples here. So the first example is y minus 4 everything squared equals to x plus 3. Okay, so if you want to sketch this, remember what's the turning point form? It's y minus k everything squared equals to a squared times x minus h. All right, so looking at this, you can see k is 4, and then a is just a squared, a is just 1. And then look, this is plus 3, but we want minus h, which means k would be 4, but h is negative 3, because you need to go x minus minus 3 to get you x plus 3. Okay, so the h value is negative 3, which means that, and the a value is positive, so then a is equals to just 1, right? Because that would be brackets and then times by 1 squared. Okay, it's positive coefficient of x, which means it will look in this shape here, and the turning point is negative 3 and 4, right? H comma k. So x is negative 3 is here, y is 4, which will be roughly around here, and that will be there. All right, so it's just going to the right hand side here, but would it cross through the x-axis? I'm not sure, so let's test that out. So you would let on the x-axis, let y equals to 0, then you get 0 minus 4 everything squared equals to x plus 3. So then negative 4 squared is 16 equals to x plus 3, so 13 equals x. This is the x-intercept. Right, so 13, let's say it's roughly somewhere around here. So yes, it does cross to the x-axis at the point 13. Now where does it cross to the y-axis? There will be 2 points. And now to solve for this, you actually need to set x equals to 0. So let x is equals to 0. then you would get y minus 4, everything squared is equals to 0 plus 3, which is 3. So y minus 4, everything squared would be 3, and so y minus 4 would be plus minus square root of 3. Remember, when you open up a square, right, when you square a number and you get another number, the original number could be either positive or negative of square root of the other number. So then y would be move the 4 over, 4 plus minus square root 3. Now, square root 3, if you haven't guessed, this one will be about 1 point something, right? Just a quick recap. Square root 1 is 1, square root 4 is 2. So square root 3 is somewhere in between, which is 1 point something. So 4, even though you plus or minus 1 point something, it will still be positive, and that makes sense, right? The center is at 4, so when you plus square root 3 to the y-axis, you get 4 plus square root 3 as the top one, and then the bottom will be 4 minus square root 3 as the other y-intercept. There are two y-intercepts here. Alright, let's move on to question B here. Y squared plus 2y equals to, so y squared plus 2y equals to 2x plus 3. 2x plus 3. Okay, recap, what is the turning point form? The turning point form is y minus k everything squared equals to a squared times x minus h. Now note that this is the perfect square of y, right? This is not a perfect square of y, so we need to get a perfect square, we need to complete the square. Okay, so let's see how we complete the square. Now, a completed square would be in the form of a squared plus 2ab plus b squared. Right, so we've got the a squared, which is y squared, and then 2ab, which is 2y, which means that 2 times 1 times y, or 2 times y times by 1. So then the b squared term that we need to add would be 1 squared. So basically, it's just half of the coefficient of the 2ab term. So that'll be plus 2 times a times by b, which is 1, and then we need to add the b squared term and then subtract the b squared term. And that will be equals to, now we want 2 on the outside, so 2 times x plus 3 over 2. Alright, so we're going to take out the 2 first. Actually, I'll leave it be. Okay, now we complete the square on the left hand side. That will be y plus 1 everything squared, and then minus 1 equals to 2x plus 3. So y plus 1 everything squared would be, bring the 1 over here, that would be plus 1, so that would be 4, so 2x plus 4. And then I take out the coefficient 2, then you would get x plus 2 in here. Okay, so this is in that form already. So what's a, h, and k? Okay, so a squared is equals to 2, right? Is that value there? Y minus k, so k would be negative 1, and x minus h, so h would be negative 2. So given this would be the normal graph, right? Because the coefficient of x is positive, it will be a normal, normal sideward parabola to the right. And then the turning point then would be h comma k, which is negative 2, negative 1. Right, let's sketch it. X is negative 2, y is negative 1. So the turning point would be somewhere around here. Now we need to find where it meets the x-axis. Okay, we know it roughly goes over here, but is it like that, like this, or like that? We don't know. So we need to find the x-intercept first. So let y equals to 0. Then you would get 0 plus 1 everything squared is equals to 2 times x plus 2. Okay, so 1 squared is 1, divided by 2 is 1/2, equals to x plus 2, minus that over, so negative 1.5 would be equals to x. So negative 1.5, which is, let's say that's negative 1, so negative 1.5 is somewhere around here. Alright, so then this graph would look somewhat like that. And then on the other side, it will have to mirror and look something like this. Okay, so, and then to find the y-intercept, you would let x equals to 0. And so you get y plus 1 squared equals to 2 times 0 plus 2. Okay, so then y plus 1 everything squared would just be 2 times 2, which is 4. This is a nice number. So y plus 1 would be plus minus 4. Now then y would be minus 1 plus minus 4. To actually get the values, you need to split that up. So y is either minus 1 plus 4 or y is minus 1 minus 4. Okay, so then I'll get y equals to positive 3 or y is equals to negative 5. Alright, so these are the two values. So y is negative 5 here, that would be the first y-intercept, and then positive 3 would be the other y-intercept.